doing distance formula stuff, remember the easiest thing to do is remember that distance formula is nothing but just Pythagorean theorem. So if you've got your ordered pairs of -2 and 7, -6 and 2, think of it as some horizontal distance, some vertical distance. You got to find the diagonal. How far apart is -4 and -6? Distance is distance positive or negative? This is always positive. Bless you. How far apart is 7 and 2? So then you just throw that in your calculator, 5 squared plus 4 squared. And then it gives you, like I said, it'll do simplified radical form. Yeah, you get square root of 41. Yes, ma'am. 14. That's simplified radical form means. Okay. Next one that you're talking about. Nice. Okay. You're facing towards me. It's enough. If this is all it takes to get you to do so, that's great. Excuse me. I don't think so. Not every once in a while you come across one. If you haven't done a certain style in a while, you always refresh it. It doesn't happen as much in geometry for me as it does in altitude because there's certain things in altitude that you don't use very often. It's just to get to the next level and all that. I'll redo a bunch of homework and stuff like that with those classes. With you guys, there's a few points like we did like centroids and things like that. It only shows up for a week, and you get to refresh a lot of that. And most of these things, it's pretty straightforward. It just matters of following directions there. Yes, sir. It's a culminating event of a semester. It's basically finals are one of those things. As you get into college, finals become a whole lot more important than you do in high school. In college, you get basically a midterm and a final. A lot of it. Make sure you can retain information throughout the semester, that kind of stuff, and so on. So this one here. Oh, sorry. What do you got? Care. Just get it right past them. I'm not going to give a minute. This one here, following instructions on it tells you had certain parts that were equal, and you had to make your tick marks accordingly. In this case, it said that you had AB was concurrent to BC, and AC was concurrent to CD. So when you fill in those things and you're looking at it in terms of the diagram, even though the picture itself might not be drawn to scale, which is fine, then you know you have to go 2x plus 3 plus 2x plus 3 equals to 5x minus 5. That's how that one's going to work. By following the directions via the diagram, you can only do that. Combine your like terms. Excuse me. Move stuff around. You get x is 11. But just like most of the times in geometry, it's not just solve for x. Do something with it. Instead, find BC. Well, BC is the same thing as AB. So 2 times 11 plus 3, that'd be 22, and 3 is 25. Yes, sir. Because these two are the same, and then the whole thing and this thing are the same. Okay. Diagram below, RZT is 120. Draw the diagram. If the whole thing is 120, RZS is 6x minus 3. SZT is 10x and 5. Well, that's angle addition. Two smaller angles add up to equal the larger. So happens you know what the larger has to equal. It's going to have to add up to equal 120. So 16x and 2. What's up?
It's supposed to be 6x minus 13.
Oh, sorry, I didn't see that. 13. Change that real quick. So we 16x minus 8 is 120. Excuse me. And I think x is 8, if I'm not mistaken. Okay. And obviously, it looks like something I might have gotten cut off about what you would do. Find the measure of QXR if XS bisects RXT, and QXR is that, RXS is the other. You bisect an angle, what do you do to it? Correct. So here's Q, X, T. So XS bisects RXT. So these two angles here are the same. QXR, 3x and 3. RXS, 4x, 6. Which means SXT has to be what? Same thing, 4x plus 6. What do all three of those have to add up to equal? All three of those create lines that add up to 180. So we have 3x and 3, 4x and 6, 4x and 6, 7x, 11x, 6 and 6 and 3 is 15. I believe you should get 15 as well. And then find QXR. 3 times 15 is 45. Add 3, you should get 40. Sequence patterns. 5, 10, 20, 40, what's next? Ooh. 80, then what? 160, then. Multiplied by 2, very good. Identify the pattern. 5, 10, 20, 40. Well, times 2, times 2, times 2, and so on. So you're going to get 80, 160, 320, and so on. 81, negative 27, 9. One of the tips that you'll find when your sequences alternate signs means they're having multiplied or divided by a negative. What do you divide 81 by to turn into negative 27? You only had a calculator, you could try to figure these things out. negative 3. So what's 9 divided by negative 3? Negative 3. What's negative 3 divided by negative 3? 1. There you go. Next one's really tricky. 2, 3, 5, 8. What is it? What is it? 13? And what's the next one? Excellent. Nice job, Santana. Nice job, man. 2 plus 3 is 5. 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 8 is 21. Nice job. It's usually pretty tricky. Algebra 2, we do a whole bunch of things on sequence patterns. If you pick those things up, you'll fly right through that stuff in Algebra 2. Yes, ma'am. Plus 1, plus 2, plus 3, plus 5, plus see how it doesn't, it's not the same thing. If it was plus 1, plus 2, plus 3, the next one would have been plus 4, would have been 12, then 17. Oh, I see what you're saying. If that's the pattern you were picking up on, plus 1, plus 2, plus 3. You know what? You wouldn't be wrong. You wouldn't be wrong. You're right, because you can't say that that's wrong. From the 4 terms, you're right. 2, 3, 5, 8, and then you said, so this is plus 1, plus 2, plus 3, plus 4, plus 5, so it would be 12, 17. Yeah, you wouldn't be wrong. Yeah, I would say there are 2 different answers to that one. That's good. I didn't think of that. Correct. When we do stuff like that, the test-wise, we get rid of the ambiguous idea. We've gone through it many times. We've had many people check the different answers. So we should not have more than one answer. Okay. This just winds up being one of those weird examples. Good pickup, though. I didn't think of that. Circle, triangle, square. Circle. What's next? Triangle, then square. Okay. Now, when things start to get interesting, so it recycles itself every 3rd time. Okay. So it's pretty easy to figure out what the 7th term would be because you can just write it out. What's the 7th term going to be? Circle. Okay. It'll be a circle. Now, what I want you to do is think of this as you've got your terms of 1, 2, 3, 4, 5, 6. The 7th term. It repeats itself every 3rd. What is 7 divided by 3? Let's go back to old school way of doing it. My son right now is doing long division. They're doing like 3-digit long division, stuff like that. They're working with remainders. How many times does 3 go into 7? Twice. You put a 2 up here. You'd multiply. You'd subtract. And what do you do with that 1? What do we call that? It's a remainder. So back in the day, you'd call that R1. So think about the term of the sequence. 1, 2, 3. 1, 2, 3. 1. The remainder tells you where it's at. Okay. Look at it if you go to 113. 3 goes into 11 how many times? 3 times 3 is 9. Subtract it out. We get 23. 3 goes into 23 how many times? 7. 21. Remainder of 2, which means it needs to be a triangle. remainder tells you where you're going to be. Remainder of 1, it's a circle. Remainder of 2, it's a triangle. What's that? For what? What's 113 divided by 3? Because there's only 3 different patterns. Circle, triangle, square, there's only 3 of them. Try to find where it repeats itself. It repeats itself every 3rd time. So if you had, let's say it was 100, or I know this one's not on here, but let's say you had to figure out the 237th term. 3 goes into 23 how many times? 7, 21. 3 goes into 27 how many times? 9. Now that means that there's no remainder, right? Which means it's going to be a what? There's no room. It's going to be a square because the remainder of 3 means it's a whole number. Yes, ma'am. After you've learned how to do remainders back in 4th grade, we took it a next step further. This is technically 37 and 2/3. 2/3 is 0.6 repeat. That's what happens if you're divided by 7? What if there's seven shapes? Right, but then you have to figure out what your remainder is. So that's where I'm going with that. Okay. If you had hexagon, heptagon, circle, square, triangle, hexagon, heptagon, square, circle, triangle, and you had those, let's say just 5 of them, you'd be divided out by 5 to figure out what the remainder is, figure out what it applies. Not sure where you're going with that. Hypothesis and conclusions. If 2 angles are vertical, then they share a vertex. What's the hypothesis? If. The if part. Therefore, the conclusion would be the then. Counterexamples. The sum of 2 numbers is always greater than it's always greater than the 2 numbers. Remember, a counterexample is anything that disproves something. The sum of 2 numbers is always greater than the 2 numbers. Give me a counterexample. What do you got? Correct. Works for me. Perfect. -1 plus -1 is -2. Smaller than both the other numbers. 0 plus 0 is 0. Smaller or is bigger. Okay. Same idea. Very good. That works. If a parallelogram has 4 congruent sides, then it's a square. Rhombus. Very good. You just got done with those. Converse, inverse, contrapositives. P, Q, Q to P, not P, not Q, not Q, not P. First one is, if a polygon is a triangle, then it has exactly 3 sides. So if you say that backwards, if the polygon has 3 sides, then it is a triangle. True or false? True. If it is not a if it is polygon is not a triangle, then it does not have three sides. True. If it is polygon does not have three sides, then it is not a triangle. True. In this case, all of them are true. And that's what that looks like. If Jared is in 11th grade, then Jared is in high school. Okay. If Jared is in high school, then Jared is in 11th grade. But that also that's the false one because he could be in 10th grade. Could be in 9th grade. If Jared is not in the 11th grade, then he is not in high school. Okay, you can reuse that same counterexample that he could be sophomore, freshman, or senior. And then if he is not in high school, then he is not in the 11th grade. That works. Excuse me. Detachment or syllogism? Detachment was the one that was very, very choppy. Syllogism was the really simple one. A equals B, B equals C, A equals C. That was the syllogism. I'm taller than you, you're taller than her, I'm taller than her. It just flowed. Detachment, chop. If you want to get a driver's license, you must take driver's ed. John wants to get a driver's license. John needs to take driver's ed. Is that detachment or syllogism? Detachment is chopped. Okay? The true part of detachment is repeated. That's where it comes from. I'm really sinused up again. I don't know why I can't hear this. You have to be louder. What was it? And then write down what the next step would be. So like I just said, if you want to get driver's license, you must take driver's ed. John wants to get a driver's license. Okay? By law of detachment, John must take driver's ed. That's what well, yeah, you just say what conclusion you come up with. John must take driver's ed. Because of the law of detachment. Your thing. You go to the next one. Yes, sir. How you doing? Let's go to the next one. If you miss more than 5 days of math, you will not get a good grade. If you're not getting a good grade in math, you'll not be on the honor roll. That's your syllogism. If you miss more than 5 days of math, you will not be on the honor roll. It could be true or false. They're just looking at the statement itself. I would put it on your lips. I'm going to go ahead and say no, Bryn. It's not a good idea. You know, looking out for your well-being. If you buy the newest video game, you do not have enough money for lunch. You don't have enough money for lunch, you will not eat. Again, there's syllogism. You buy the newest game, you will not eat lunch. Marla likes milk. She also likes orange juice. Marla chooses milk to drink. She cannot have orange juice. It's a weird combination, and it just doesn't make any sense. This one has no conclusion. There's not. It's neither. Yeah, there's no syllogism or detachment there. Yeah, milk. No, I'll drink milk. I'll drink orange juice. But when you drink, you have like a glass of both at the same time. It's just weird. Yeah, oh yeah. Oh, fridge is about to fall in. 14 and 15, these are pretty quick. How do you solve for x on 14? You guys set them equal to each other because what kind of angle pair relationship are they? Vertical. Add, subtract. 2x is 100. What do you do with 15? Yeah. I asked you guys kind of go through a little bit of three. I don't know how far you got. I only said try to get the first couple of them. So let's just review angle pair stuff real fast. Angle pair relationships, you had four types of angles that we dealt with. We had corresponding, alternate interior, alternate exterior, and consecutive interior. And it's just a matter of figuring out which ones are which. Corresponding were same side, same position. Those. Alternate interior were on the inside, opposite sides. The exterior stuff was the same basic idea, but on the outside. And then the consecutive interior were same side inside. Like these two. Consecutive interior, if they were parallel, were what? Were they the same, or different, or different? Or actually, could they be the same? They could be the same, but what do they always add up to equal? 180. Yeah. Same side inside, consecutive interior always be 180. Okay. So as you're going through this big old diagram here, you had two sets of parallel. And we're looking at 2 and 10. What are those? Corresponding. Very good. 3. 3 and what would be alternate interior? 3 and what are alternate interior? Two sets of parallel sides, guys. Turn your head sideways. Thank you for paying attention. Turn your page like that. There's two sets of parallel sides, guys. Change your perspective. 3 and 7 are alternate interior. 9 and 8. 9 and 8. 9 and 8. What are those two? Louder, louder. Consecutive interior. Excellent. Then they start talking about how do you show which ones are to prove things at work. So we have A and B. Angle 11 here. If I want to know that lines A and B are parallel, if I wanted to say what angle is congruent to 11 to show that those two lines might not be in parallel, that means that this has to be my transversal. Okay? What's the only other numbered angle that would have to be congruent to 11 according to the diagram? 9. Very good. 9 would have to be the other one because this is corresponding. And what relationship is 6 and 11 to show that C and D are parallel? Consecutive interior. So 6 is here, it's 50. What was 11? 130, good. Then they go to another one. If 2 is 70, what's angle 6 going to be? 7. Again, hopefully you're turning your stuff just to see the pair, so you have alternate interior then. So it has to be 70. Angle 1, 130. Angle 5, 130, very good. Alternate exterior, they both have to be 130. And 7 is 110. Find out what 10 is. How much? 7, very good. For the one I just did? Alright, so this one was 130 here. So if you turn your page like this, it's looking for this angle here. These guys match up. 130 and the outside, they're exterior angles, they're alternate exterior. So it has to be. On number 8, it says find if measured angle 1 is 130, find angle 5. Yeah, those just words. Okay. And then lastly, it said 4 was 45. What does 12 have to be? So for the rest of the time, just keep working. I want you guys just to finish up this 3 stuff. We'll have a couple of minutes here. You still have what? I know, but you guys can work on it in case you haven't done these 5 problems. Take a couple minutes. What, on number 11? Do you want to do that? I mean, no. Well, first things first, what's y equal? 30. What do 3 angles in a triangle have to add up to equal? Okay, what's x plus x plus 20 plus 30 has to equal 180? You just got a bunch of vertical angles and supplementaries. Yeah. Great conversation. What was that? For me, for what? On 14? What's the supplement to 115? What? Yeah. With 2 lines that intersect, you get 4 angles. They're either going to be equal or supplementary. Don't overthink it. You're overthinking it. You're overthinking this. You're right, that's 115. Don't these 2 make a line? Don't overthink it. See what I'm saying? And then you just figure out the numbers. Hear what I'm saying. Uh, 149. Yeah, sounds about right. Yes. And that's usually when finals come around, you're like, oh yeah, I forgot about that. Real fast, we'll scroll through 15 real quick to make sure everybody sees what's going on here. On 15, they give you a bit of information. As soon as they put two right angles on a transversal, that automatically means the lines that are perpendicular to it have to be parallel. That's what that means. So then you've got these two parts here and here. So 5a minus 43, 7a minus 17. So remember, we don't know if we've set each other or the supplementary. What we do is we make our tick marks through. If they match up with tick marks, they're equal. If they have a tick mark and don't have a tick mark, they have to be supplementary, no matter what. So those two angles have to add up to equal 180. So you have 12 minus 60, 180. Yeah, it's 1. Do the same thing with the B values. You just work your way through to see if they match up, or if they don't. If they match up, they're congruent. In this case, they wind up doing it. It depends on what it asks you. Here, I think I didn't specifically say. It might just say, for something like that, it might just say find the measure of angle. Or it might just say find A or find B. Okay. Hmm? How much is it? Oh, I was sure. I thought you said 67. Like, okay. Not the scale. Believe the values, don't believe the picture. Okay. Yes, ma'am. For 8, yeah, 8B, those two have to be equal to each other, yeah. No, all you have there is if you follow the tick marks, you have your 8B here. Just redraw your tick marks. Just set them equal to each other. What do we mean by all of them? These two, we already solved for A. It's a different transversal. Yeah. Make sure you guys get through 4, which means I want you to do the fill the blank group stuff on the back. And then start the first page of 5 for one day. So that way Tuesday we can finish up 5 and any leftover stuff in 6.